Time. It marches forward, relentless and unforgiving. But what if we could control time? What if we could turn back the clock, relive past glories, or steal a glimpse of the future? This is the tantalizing promise of time travel. The allure of time travel is deeply rooted in our desire to explore the unknown. Just as we yearn to discover new lands, we long to unravel the mysteries of time itself. Time travel offers us the ultimate escape, a chance to break free from the constraints of our linear existence. But is it merely a fantasy? Or could there be a scientific basis for our dreams of bending time to our will?
The seeds of time travel were sown long before the advent of modern science. Ancient myths and legends are replete with tales of mortals venturing into otherworldly realms where time flows differently. H.G. Wells's groundbreaking novel, The Time Machine, published in 1895, is widely regarded as the seminal work of time travel literature. Wells's tale of a Victorian scientist who invents a device capable of traversing the fourth dimension captured the imaginations of readers worldwide. Following in Wells's footsteps, countless authors have woven intricate tales of time travel, exploring its myriad possibilities and consequences. Cinema, too, has embraced the allure of time travel, bringing its wonders and perils to life on the silver screen. These stories, both in literature and film, serve as more than just entertainment. They are thought experiments, exploring the philosophical implications of time travel.
For centuries, time was seen as absolute and unchanging, a universal constant ticking away at the same rate for everyone, everywhere. Then came Albert Einstein, who, with his groundbreaking theories of relativity, shattered our intuitive understanding of time and space. Einstein revealed that time is not absolute but rather relative, dependent on the observer's frame of reference. This means that time can pass at different rates for observers who are moving relative to each other or experiencing different gravitational fields. Einstein's special theory of relativity, published in 1905, introduced the concept of time dilation. Time dilation states that time slows down for an object in motion relative to a stationary observer. The implications of Einstein's theories for time travel are profound. If time is relative and can be warped by gravity, then perhaps it's possible to manipulate time, to stretch it, compress it, or even bend it into loops.
Einstein's theories of relativity provide the framework for time travel but present formidable challenges. Traveling through time requires bending space-time, creating shortcuts through reality. One such shortcut is a wormhole. Imagine space-time as an apple. A worm creates a shortcut through it. A wormhole connects 2 points in space-time, potentially separated by vast distances. Even if they exist, wormholes would likely be unstable and short-lived.
The prospect of time travel is undeniably captivating, but it also raises a host of perplexing paradoxes and logical conundrums that have plagued philosophers and physicists for decades. One of the most famous of these is the grandfather paradox. Imagine traveling back in time and meeting your grandfather before he met your grandmother. Now imagine accidentally causing his demise. If your grandfather died before having children, then how could you, his grandchild, exist to travel back in time in the first place? Another mind-bending concept is the idea of temporal duplicates. If time travel is possible, then what's stopping you from traveling back in time and meeting your past self? These paradoxes have led some physicists to propose the Novikov self-consistency principle, which states that if an event has a non-zero probability of causing a paradox, then the probability of that event happening is zero.
Quantum leaps and possibilities: modern physics and the quest for time travel. While Einstein's theories of relativity provide the foundation for our understanding of time, the strange and counterintuitive world of quantum mechanics offers intriguing new avenues for exploring the possibility of time travel. Quantum mechanics governs the behavior of matter and energy at the atomic and subatomic levels, where the rules of classical physics break down. One of the most bizarre aspects of quantum mechanics is the concept of quantum entanglement. This phenomenon occurs when two or more particles become linked, even when separated by vast distances. Some physicists believe that quantum entanglement could potentially be harnessed to create wormholes, providing shortcuts through space-time. By entangling particles at different points in space-time, it might be possible to establish a connection between them, creating a bridge through which information or even matter could travel.
The ethics of time, moral dilemmas, and potential consequences. The prospect of time travel raises a host of ethical and philosophical questions that challenge our understanding of free will, responsibility, and the very fabric of history. If time travel were possible, it would fundamentally alter our relationship with the past, present, and future. The ability to alter past events, even seemingly insignificant ones, could have unforeseen and potentially catastrophic consequences for the present. Imagine traveling back in time to prevent a tragic accident. While your intentions may be noble, your actions could inadvertently set in motion a chain of events that lead to a far worse outcome. The past, once considered immutable, would become a fragile and potentially dangerous landscape to navigate. The ethical implications of time travel extend beyond the potential for altering the past. The very act of traveling through time raises questions about personal identity and responsibility.
A future in flux, time travel's impact on history and identity. The implications of time travel extend far beyond the realm of individual morality. The ability to traverse time would have profound societal and historical consequences, reshaping our understanding of the past, present, and future. History, once considered a fixed and immutable record of past events, would become fluid and open to interpretation. If time travel were possible, who would control access to it? Would governments use it to rewrite history in their favor, erasing inconvenient truths and shaping narratives to suit their agendas? The potential for abuse is undeniable. Imagine a world where the wealthy elite could alter their own pasts, erasing mistakes and ensuring their continued dominance. The very notion of justice and accountability would be called into question.
The undying allure. Time travel's hold on our imagination. Despite paradoxes and ethical dilemmas, the dream of time travel persists. It captivates our imaginations, fueling science fiction, inspiring inquiry, and igniting debates. The allure lies in its promise of ultimate freedom. It tantalizes us with escaping our linear existence, righting past wrongs, and glimpsing the future. Time travel represents the quest for knowledge and control, transcending our limitations. It speaks to our fears, aspirations, and fascination with the unknown. Whether a dream or reality, time travel will continue to inspire and captivate us.